hardware's shifting fault lines. For 15 years, NVIDIA maintained a clean market segmentation between consumer and enterprise GPUs using a single lever, double precision floating point. On the Fermi architecture in 2010, GeForce cards were driver capped to a 1.8 FP64:FP3:2 ratio while Tesla units kept 1:2. By Ampere in 2020, the consumer ratio had widened to 164. So thoroughly that NVIDIA's own GA102 white paper described the residual FP64 units as existing merely to ensure any programs with FP64 code operate correctly. A detailed analysis of this 15-year degradation curve finds that FP64 throughput on consumer GPUs increased just 9.65x between 2010 and 2025, 0.17 to 1.64 T FLOPS, while FP32 surged 77.63x. The enterprise-to-consumer price gap widened from roughly 5x in 2010 to over 20x by 2022, with FP64 as the convenient justification. Now the AI boom is dismantling that logic. Modern training lives comfortably in FP16, BF16, FP8, and even FP4. Precisions where consumer GPUs are surprisingly capable. The Blackwell B300 takes the reversal to its logical conclusion. FP64. FP3, 2 drops from the B200's 1.2 to the B300's 164. The same ratio as a consumer RTX 5090. As dedicated FP64 silicon is cannibalized for NVFP4 tensor cores. Peak FP64 collapses from 37T FLOPS on B200 to 1.2T FLOPS on B300. NVIDIA is betting on FP64 emulation via the Ozaki scheme, which splits double precision numbers into FP8 slices, multiplies them on tensor cores, and reassembles the result in FP64. The next segmentation line is likely to shift from FP64 to low-precision tensor throughput, where B200 offers a 16:1 FP16:FP3:2 ratio versus the RTX 5090's 1:1. The capital commitments are recalibrating too. NVIDIA and OpenAI reportedly walked away from an unfinished $100 billion joint venture, settling instead on a $30 billion investment. A signal that even the most capital-flush players in AI are tightening scope rather than doubling down indefinitely. Meanwhile, Google released Gemini 3.1 Pro with updated benchmarks, maintaining the relentless cadence of frontier model drops that keeps hardware refresh pressure high. Local AI comes of age. The team behind llama.cpp, the C/C++ library that made local model inference practical for millions, is joining Hugging Face. GGML creator Georgy Gerganov and his team retain full technical autonomy. HF provides long-term institutional resources. The concrete deliverable, near single-click integration between HF's Transformers library, the source of truth for model definitions, and llama.cpp's inference engine. As local inference becomes a competitive alternative to cloud endpoints, the packaging gap matters more than raw capability. HF is positioning llama.cpp as the ubiquitous local inference layer that runs as efficiently as possible on our devices, with shared ambitions to make open-source superintelligence accessible to the world. One enterprise team demonstrates the practical endgame. 2 NVIDIA DGX Spark units, $8,000 total, deliver 256 GB unified memory and 2 PFLOPS running Alibaba's Qwen 3 coder next. An 80 parameter MOE model with only 3B active parameters per inference and 256K native context. At Q8 quantization with 0 API costs. The team deploys it as an agentic coding assistant that implements across multiple files, delivers PRs with blast radius analysis, and runs a shadow engineering agent that watches human PRs and flags quality issues continuously. Agent orchestration remains harder than expected. The model occasionally hallucinates file paths or refactors signatures without updating all call sites, requiring validation loops the agent runs against its own output. Commenters noted the $8,000 represents 40 months of a Claude Max subscription. The ROI depends heavily on throughput, concurrency, and data sovereignty requirements. The sovereignty angle matters more than the team expected. Every prompt, every model weight stays in building. The tooling ecosystem continues broadening beyond developer terminals. Velium, a new open-source desktop app, brings visual controls for creative writing with local models to non-technical users. Bloom filters in the transformer brain. Some transformer attention heads appear to function as membership testers, dedicating themselves to answering, has this token appeared before in the context? A new interpretability paper identifies 3 such heads in GPT-2 small L0H1, L0H5, L1H1, One that form a multi-resolution membership testing system concentrated in layer 0. 1. Taxonomically distinct from both induction heads and previous token heads. The evidence is precise. Head L1H11 follows the theoretical Bloom filter capacity formula K equals sign 1 hash function, about 22 fitted capacity bits, saturating by about 40 unique context tokens. The other two heads are more interesting. They maintain false positive rates of 0. 4% even at 180 unique tokens, well exceeding classical Bloom filter bounds and suggesting a richer mechanism than simple bit array hashing. A similarity sweep across 1,284 controlled probe tokens reveals that false positive rates decay monotonically with cosine distance in the embedding space. Consistent with locality-sensitive hashing, not uniform hashing. The hash functions are the QK projections themselves. L0H5 ultra-precise reaches noise floor by cosine 0.5. L1H11 broad retains 17% false positive rate at that threshold. Together, the three heads give the model membership signals at multiple similarity resolutions, paralleling the multi-granularity Bloom filter designs human researchers proposed deliberately. A fourth candidate, L3H0, was reclassified as a generic prefix attention head after confound controls revealed its capacity curve was a sequence-length artifact. A self-correction the authors argue strengthens the surviving findings. The practical implication is immediate, because these heads are already computed during inference. Monitoring their false positive activations provides a zero-cost hallucination diagnostic at the layer where the error originates. The deeper scientific point is striking. Gradient descent, optimizing nothing but next token prediction, converges independently on a variant of the distance-sensitive Bloom filter that human researchers took 36 years to formalize. Ironically, throwing more compute at inference doesn't reliably help. An evaluation of 22 model configurations on Deep Research Bench 169 web research tasks. Human-verified answers found that GPT-5 at high effort scored 0.481 versus 0.496 at low effort, while costing 55% more per query, 39 cents versus 25 cents. Gemini 3 Flash showed a 5-point drop from low to high effort. The researchers' takeaway: minimal effort settings often occupy the Pareto frontier for accuracy per dollar. Why enterprise agents keep crashing. IBM Research and UC Berkeley applied MAST multi-agent system failure taxonomy to IT Bench, the industry benchmark for SRE security and FinOps automation, annotating 310 execution traces across 3 model tiers. The results map the failure landscape with unusual precision. Frontier models like Gemini 3 Flash fail surgically. 2.6 failure modes per trace, typically hitting an isolated bottleneck. Large open models like GPT OS-S120B suffer cascading collapse. 5.3 failure modes per trace, where a single reasoning mismatch early in a run poisons the context and compounds into total derailment. The taxonomy identifies 14 distinct failure patterns across structural looping: memory loss, premature termination, communication inability to clarify, going off topic and quality control categories, incorrect verification, hallucinated success. The single strongest predictor of failure is FM3.3, incorrect verification. Agents declaring victory without checking ground truth. For Gemini 3 Flash, verification errors spike 52% in failed traces versus successful ones. Kimi K2 has a different pathology: a plus 46% premature termination rate and a staggering 92% prevalence of reasoning action mismatch in failed runs, where the model identifies the correct next step then executes an irrelevant command. GPT OS-S120B loses conversation history in the majority of its traces versus 0 for Gemini, and 87% of failed runs show decoupled reasoning and action. The crucial finding: prompt engineering alone yields about 15% improvement. Architectural interventions. Context management agents, finite state machines for termination, deliver up to 53%. 2 models can share the same success rate yet fail for entirely different structural reasons requiring entirely different fixes. This pattern surfaces independently in a forensic audit where one user found 40.8% of their local AI assistants claimed task completions were outright fabricated. A blunt reminder that verification cannot be optional. OpenAI's newly published Practical Guide to Building Agents arrives as if timed to this diagnosis. It advocates layered guardrails, relevance classifiers, safety classifiers, PII filters, tool risk ratings operating concurrently with agent execution, single-agent first design with multi-agent architectures reserved for high-complexity workflows, and explicit human intervention triggers for high-risk or irreversible actions. The most practical recommendation: never let the LLM grade its own homework. building agents that survive contact with reality. If incorrect verification is the Achilles heel, Daniel Miessler's generalized hill climbing runtime proposes making verification the entire architecture. Built on top of Claude Code, the framework centers on ideal state criteria ISC. 8 12-word, binary testable, Boolean statements that define success before any work begins. Every request is reverse engineered. What was explicitly asked for? What are the gotchas? What common failure modes exist? The resulting ISC serve as both specification and verification gates. An effort-level controller scales the machinery from instant fixes 4. 8 criteria to deep system redesigns 40. 150-plus criteria with parallel agent spawning and multi-agent debate. The inner loop is the scientific method. Observe, hypothesize, test, iterate, running against the outer loop of current to ideal state. Miessler reports meaningful reduction in drift and rework when ISC are combined with execution in waves, with deterministic gates between waves that check deliverables before authorizing the next phase. If you can't articulate what you want, prompting and context won't help you much. The build with quality skill demonstrates what this looks like at scale. A 111-agent swarm in a hierarchical mesh topology across development, quality, and security domains. Its validation project. Shopflow V2, a 220-line e-commerce platform with 6 bounded contexts, 5 architecture decision records, and 90% plus test coverage, was built in a single session with real Stripe payments and PostgreSQL persistence. Agents communicate laterally. The test generator knows what the coder built. The security scanner feeds findings to the architect. The explicit pitch. Can AI write code? Yes. So can offshore teams. The question is whether it can write code your team can maintain. The mounting cost of AI slop. AI slop PRs are becoming increasingly draining and demoralizing for Godot maintainers. Writes Godot project manager Remy Verschelde. Capturing the central tension in a detailed examination of AI-generated code's impact on open-source economics. The problem isn't bad code, it's convincing code. It compiles, it passes superficial review, and it looks professional. But it may embed subtle logic errors, security flaws, or unmaintainable complexity, notes Hizo AI CTO Peter Winkelek. A contributor generates a 500-line PR in 90 seconds. A maintainer still needs 2 hours to evaluate it. The cost of producing code has cratered to near zero. The cost of reviewing it hasn't budged. One researcher found that about 20% of package names in AI-generated code don't even exist. And attackers are already squatting those phantom names, turning hallucination into a supply chain attack vector. The irony. Some enterprises move to open source specifically to escape hyperscaler AI risk, only to discover AI-generated code now flowing into open source itself. As one consultant put it, AI slop creates a false sense of velocity. You think you're shipping faster, but you're actually accumulating risk faster than your team can pay it down. The Think Tax editorial frames this as cognitive atrophy, not tooling failure. Every AI-generated function accepted without building a mental model defers a payment that compounds exponentially. Anthropic's own research found developers using AI scored 17% lower on comprehension when learning new libraries. Stack Overflow's 2025 survey puts AI tool usage at 85% of developers. A systemic comprehension gap forming across the industry. The progression is predictable. A honeymoon where AI delivers genuine productivity gains. A drift where probably won't break becomes the approval standard. And a cliff where debugging becomes archaeology. The analogy is uncomfortable. GPS killed spatial awareness. Autocorrect degraded spelling. Autopilot created pilots who can't hand fly in emergencies. The dangerous part is that underload feels great. You're productive. Things are shipping. The feedback loop is all positive. Right up until the moment you need to debug something and realize you have no intuition about how the system behaves. Vector databases continue finding novel applications beyond chatbot RAG. RuVector's DNA sequence analysis example demonstrates embedding-based similarity search applied to genomic subsequences, where structural similarity queries replace exact matching for bioinformatics applications. Agent security under the microscope. Shanghai AI Laboratories Trinity Guard addresses the agent safety gap with a framework covering 20 risk types across 3 levels: single agent risks jailbreak, prompt injection, hallucination, memory poisoning, tool misuse, interagent communication risks message tampering, malicious propagation, goal drift, identity spoofing, and system-level risks cascading failures, sandbox escape, rogue agents. Both pre-deployment testing and progressive runtime monitoring are supported, with an LLM-powered global coordinator that dynamically activates specific risk monitors based on conversation context. Built on AG2, /autogen and aligned with the OWASP Agentic AI Security Top 10, it provides the systematic safety testing that enterprise deployments need before agents touch production data. HackMyClaw demonstrates why such frameworks matter. The adversarial challenge pits participants against few. A Claude Opus 4.6 powered assistant with prompt-only security instructions 20 lines telling it never to reveal secrets.env. Participants send emails with prompt injection payloads. Invisible Unicode characters, multi-step reasoning exploits, social engineering. And successful extraction of API keys earns $300. The creator's expectation is explicit. State-of-the-art models are not unhackable. Google has already had to reinstate the bot's email after takedown. A viral video walkthrough of OpenClaw shows the other end of the spectrum, giving an LLM full control of a Kali Linux machine, accessible via Telegram. The demonstration configures Claude Opus 4.6 on a cloud-hosted Kali instance, then tasks it entirely by phone, finding nearby CCTV cameras, running AUSINT on named individuals, and performing automated pen tests using sub-agents that independently install tools, select models, and produce vulnerability reports, including cracked passwords and SQL injection payloads, without the user ever opening a laptop. The framework's community skill hub already flags 12% of submitted skills as malicious, underscoring that the surface area for agentic exploitation is expanding faster than the guardrails. The privacy reckoning. A forensic teardown of LinkedIn's identity verification reveals the true cost of a blue checkmark. When users tap Verify, their passport, selfie, and biometric data go not to LinkedIn but to Persona Identities, Inc., a San Francisco intermediary most users have never heard of. The 34 pages of legal documentation disclose that Persona collects full passport data, including NFC chip contents, facial geometry from selfie and passport photo, behavioral biometrics keystroke timing, interaction pauses, and cross-references users against credit agencies and government databases. All 16 of Persona's subprocessors are US-based. Not a single EU entity in the chain. Under the Cloud Act, US law enforcement can compel disclosure regardless of where data physically sits. Persona's own privacy policy confirms compliance with law enforcement, national security, or other government agencies. Liability for breach is capped at $50. The author's verdict: I handed a US company my passport, my face, and the mathematical geometry of my skull, all for a small blue checkmark on a professional networking site. The erosion extends across platforms. Reports surface that Grok users' deleted conversation data may still be publicly accessible, raising persistent questions about what deletion actually means on AI-powered platforms. Separately, users investigating Gemini's behavior report that it appears to recall details from prior conversations it should have no access to, prompting speculation that Google may be running an undisclosed RAG layer enabling cross-session memory, a capability that blurs the already thin boundary between forgetting and never deleting.